Section 7.4, properties of exponents. All right, I'm going to make a list here of the properties of exponents, and then I will also give examples of how these work, and try to convince you that these are the right answers for these properties. Why are these properties the way they are? Not just magic, actually. All right, so let's see. Our first property is going to be, if I have b to a power, this means b times b times b times b, and there will be n factors here. This is really just a definition of exponent. And when I use this, n is a nice number. N is 1 or 2 or 3 or 4. N is one of those counting numbers. Okay, so I don't think there's anything new here. For example, if I gave you 5 squared, I'm pretty sure you'd tell me that's 5 times 5, which is 25. Or if I gave you 2 to the 4th, I think you would tell me that's 2 times 2 times 2 times 2, which is 16. All right, rule number 2. If I why did I use b? I used b for a reason. B is called the base. So that's why I use b. I use b for base. All right, rule number 2. If I have b to the n times b to the m, what do I get? Well, let's think about this for a minute. Let's say I had, go off to the side here, let's say I had 5 squared, and I was going to multiply it by 5 to the 4th. So my bases are the same. I have 5 for the base of both of them. Well, 5 squared means 5 times 5, while 5 to the 4th means 4 of them, 4 5s. So look at what I have. Altogether, I have 6 5s all being multiplied together. That, by definition, is 5 to the 6th. So when I multiply two things that have the same base, I add the powers. Rule number 3 is very similar, except rule number 3 says what happens if you divide two things. And again, the two things have the same base. It would be reasonable, I think, that we would subtract the powers. So when we multiply, we add. So when we divide, we subtract. This one has to have a little rule here. B cannot be the number 0, because I can't have 0 on bottom. But let's just see why this one does make sense. Let's say I had 3 to the 6th over 3 squared. Well, 3 to the 6th would mean I got 6 3s up on top. And 3 squared would mean I got 2 3s here. And I can reduce. I can cancel a 3 with a 3, and then a 3 with a 3. And what am I left with? I'm left with 4 3s. That's 3 to the 4th. Okay? And 6 minus 2 does give me 4. All right, rule number 4. If I have a base to a power, and then I have another power. Well, again, let's go off to the side and do an example, see why this rule makes sense. Let's say I have 4 cubed squared. 4 cubed squared, that means take 4 cubed times 4 cubed. And now I can use rule number 2 and add my powers. That's 4 to the 6th. And notice here that our powers, our original powers, were a 3 and a 2. If I take 3 times 2, I get 6. So this one is multiply the powers. 2 more rules. Rule number 5 says if I have 2 things being multiplied together, raised to a power, I take each one to the power. And that's kind of just a distributive property. And the last rule is similar. Last rule says if I'm dividing 2 things and I have a power on the outside, I can do the power on each one individually. Again, kind of a distributive property. And again, for this one, B can't be the number 0. I can't have 0 on bottom. All right, so what I'm going to do now is I'm just going to do a bunch of examples of properties of exponents, and you'll see how these work. Examples. All right, let's start with some simple ones. X squared times x to the 7th. My bases are the same. They're both x. I'm multiplying. When I multiply two things with the same base, I add the power. So that one just becomes x to the 9th. W to the 8th over w to the 6th. Kind of a similar thing, except this time I'm dividing. So this is rule number 3. When I divide, I subtract my power. So that one is w squared. All right, how about 3t to the 5th times negative 7t to the 4th. I start with the coefficients. The coefficients, fancy word for numbers out front. 3 times negative 7 is negative 21. And then I deal with my powers. 5 plus 4 is 9. So that would be negative 21 t to the 9th. All right, let's do some here that look a little more complicated. How about 14wx to the 5th y to the 9th divided by 21x cubed y to the 6th. All right, well, this one looks pretty complicated, but take it one step at a time. Start with the numbers, the coefficients. Start with 14 over 21. I can reduce 14 over 21. I can reduce top and bottom by 7. So that's 2 and a 3. And then I look at my x's. My x's, I got x to the 5th over x cubed. I subtract my powers. That's x squared. And the same thing with my y's. Y to the 6th over y to the 9th. I subtract my powers. Y cubed. All right, here's another good looking one. X, y to the 6th cubed times x squared y to the 4th. All right, the first thing I need to do is deal with this parenthesis and deal with this 3 here on the outside. So according to rule number 5, I take that cube and I put it on both pieces. So I'm going to have x cubed. And then I'm going to have y to the 6th, but then I got to cube it. That's rule number 4. Rule number 4 tells me if I have a power, and then I'm going to do another power, I multiply. So 6 times 3 is 18. That becomes y to the 18th. And then I still have x squared y to the 4th. Now I'm back to my add the powers property. So this is x to the 5th. 3 plus 2 is 5. Y to the 22. 18 plus 4 is 22. All right, a couple more problems here. How about 2a to the 6th b divided by 3c to the 5th cubed. Well, I would start inside my parentheses and I would look to see if there's anything inside my parentheses I can reduce. There isn't. So I guess all I really need to do is take this power 3 here and distribute it through to everything. So 2 cubed, 2 times 2 times 2 is 8. A to the 6 cubed, again I multiply my powers there, that's a to the 18. B cubed divided by 3 cubed is 27. C to the 15, I multiply my powers. All right. So that should give you a good example of how these problems are going to work. We'll move on to section 7.5. In section 7.5, we're going to expand our list of properties of exponents. We're going to deal with some negative exponents and deal with an exponent of 0.